Hello everyone, so in this video let us talk about a easy level problem from LeetCode. The problem name is number of even and odd bits. So let us talk about problem statement first. You are given a positive integer n, and even denotes the number of even indices in the binary representation of n, zeroth index with value 1, and similarly the odd index value. So if you see a number in its binary representation, how many bits are set in the even position and how many bits are set in the odd position, you just have to answer that in this particular way. So how can you do that? I have already covered how can you find out a bit that is set or not at a particular position in the ith position in the previous problem. If you haven't checked that out, you can check out that previous problem as well. But let's talk about in a brief in this particular problem as well. Let's say that you have any random number in its bits representation. Let's say like this. And I just have to check that. And this is like, I just give the index as well. 0, 1, 2, 3, 4, 5, and 6. I just want to check that whether the third index is set or not. How can you check that? For that, you have to somehow make a new number. You just have to make a new number in which only the third bit is set and all the other values are 0. Let's say, I'll tell you how can you make that, but let's assume that I will just make a new number in which only the third bit is set and all the other bits are 0. And if I do an AND operation of the actual number and the new number which I just formed, then if the ith bit I'm looking for, that is this bit, if I'm looking for the third bit, if it is set or not, that it is 1 or not. If it is set, then because I'm doing an AND operation, both of these values will be, you can say, matching out because both of them are 1, and AND operator will make it 1 and all the values will be 0. And because it has 1, this new number is actually a non-zero number. This will be, you can say, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. That is, this number is actually equal to 8. This number will be 8. Anything, if I want to check it, let's say the fourth bit is set or not, it will be like 1 here, something like that. But the overall idea is that it will be a non-zero value. Why? Because there will be 1 in the final number. Whatever is the AND value, the answer value has 1 at any of these bits, and for that value this number will be a non-zero number and it is a positive number. You understand? So if the bit I want to check if it is set or not, I will somehow make a new number, make a AND of the original number and a new number, and if it is a non-zero number that is formed after doing the AND operation, the bit is set. Now if I want to check the, let's say, fifth bit, let's move this out. If I want to somehow check the fifth bit, then I have to make a number in which only the fifth bit is set, all the other numbers are 0, and if I do an AND operation, all of them will be 0. Why? Because AND operation will only give a 1 if both of these bits are 1. Because both of these bits are not 1 at any position, it will give you 0, and it will turns out to be 0, which means that the ith bit I'm checking for is not set in the original number. I hope you understand. So how can you first now make this number? It's pretty much simple. This number is actually formed in which, let's say I have all the 0 number. I have a number that is 0. This is 0. Now, if I somehow just only want to introduce 1 at this point, that is 1, 2, 3, 4. 4 position left from the very start. The bit representative starts from the very back, that is this 0. So if I want to put a, let's say, you can say this is the third index, sorry. So if I want to bring a 1 at the third index from the left, I have to do this. 1 left shift 3 times. This will give you a number that is this. This is like somewhat bit manipulation techniques you have to understand this problem as well. But this is a very simple that if I want to somehow make a new number in which only this bit is set, I will take 1 left shift it 3 times and it will form you this number. This is some bit manipulation operators that you have to learn to actually solve such type of problem as well. So you can get out and check out some articles as well, but it is pretty much simple if I just tell you with this example as well. So what you will do is that to check out every bit if it is set or not, you will iterate over every bit using from 0 till all the bits possible, and for every bit you will make a new number in which only that particular bit is set and all the others are 0. You can form it using this this operation, that is 1 left shift ith number of times. So let's say I want to check 5th bit, so I will just shift 1 5 times, so it will form a number that way. Okay, that is how the numbers are formed. Now you will do an AND operation with the actual number, that is n, and it will just tell you that whether the bit is set or not. If it is set, if the ith bit is set, I mean, I know that this bit is set. I just want to check that how many bits are set in the even and odd position. So I will just check that whether the position I am on is even, then I will increment the even count. If it is not, I will increment the odd count. So I will only go in this if condition if the ith bit is set. If the ith bit is set, then I will know that, okay, check that whether the ith bit is set on the even position or odd position. Then I will get the count of how many bits are set in the even and odd position. And in the end, we'll just return out an array that is this. That is in this format as well. That is how many even and odd positions are there which are set. That's it. That's the only logic in the code part for this particular problem. This is just a for loop that is O of n, iterating over all the bits of a particular number. That's it. Complete logic in the code part for this particular problem. If you still have any doubts, you can mention in the comment box of this particular video. I will see you in the next one, coding, and bye.